Hello folks, this is Jim with Science Talk. I'm going to start here the first of a series of videos discussing currents, oceanic currents. And the first one we'll start with is up in the Arctic. Arctic warming upsets ocean currents. A spell of unusual Arctic warming has seen temperatures rise far beyond their normal levels, prompting concern over longer-term climate change. The Arctic, as it turns out, is the region of the planet where the temperature is increasing most rapidly. So this is where we see the greatest rise in temperature due to global warming. Climate change due to global warming. There are indications from the present phase of Arctic warming, tentative and inconclusive, granted, but enough to cause concern and scientific interest to suggest that the planet may now be close to one of the significant climate tipping points that could usher in drastic change. At worst, some scientists now think the North Atlantic Current, the northern part of the Gulf Stream, appears to be slowing. The current transports enough heat from tropical waters to the Arctic to keep Northwest Europe's temperature several degrees warmer than it would otherwise be, because the northern end of the Gulf Stream terminates in what is called the Jin Sea, the Greenland, Icelandic, Norwegian Sea. There it gives off its heat, and that heat helps keep Iceland, the UK, Sweden, Norway, some of the Scandinavian countries warmer than temperatures would be for their latitude location. If the North Atlantic Current changes significantly, parts of Europe would cool and sea levels would rise. Parts of West Africa could experience more drought, and the Asian monsoon might also be affected. Reports that the current may change is not new, but recent evidence from the Arctic itself has given them new urgency. In the high Arctic, it is still deep winter with temperatures dropping to minus 30 degrees Celsius, but across large parts of the Arctic, the temperature has been above freezing even at the North Pole itself. Okay, let me share with you a personal note here. I live in Fairbanks, Alaska, well, outside Fairbanks, Alaska. And that's considered the subarctic/Arctic region. Over the last now 5 winters, I have recorded temperatures at my house, and I live kind of in a low spot in the valley, so temperature's supposed to be cooler down here where I'm at. I have recorded a total of 23 days where temperatures reached minus 40 degrees Fahrenheit or colder. 17 of those days occurred in the winter 5 winters ago. The last 2 winters, I have not recorded temperatures of minus 40 degrees Fahrenheit or colder. The last 2 winters. I'm not complaining, it keeps my heating bills down, but I'm just saying, things are definitely changing here. And I am personally observing this myself by noting the temperatures at my place, and temperatures have not reached minus 40 Fahrenheit or colder for the last 2 winters. One Arctic weather station at Cape Morris Jesup in northern Greenland has regularly recorded temperatures above zero, and this winter it has so far experienced 61 hours above freezing. The previous record back in 1980 was 16 hours until the end of April. Scientists call these episodes warm intrusions, as they bring in moist, mild air. The present one is the largest on record. There's a part of the explanation is the fact that Arctic sea ice is forming later in the year, is melting earlier in the year, and so there's more open water. More open water absorbs sunlight energy, where if there was ice covering it, the ice would reflect that sunlight energy called albedo, and by absorbing the energy, well, that water is the energy is in the water, which is then released later on, adding, helping to increase the air temperatures. Also, there are other things going on. If you have open water, there are increased storms that can batter the coast, that erode the coast, and so on. But that's another story. So, we have large gaps of open water in the ice pack. Right? A lot of the ice is not forming. And as I just mentioned, this releases heat into the atmosphere. Scientists think the abnormal warming of the last 5 Arctic winters is linked to this melting. Normally, the cold winter surface water will sink vertically down as it heads out of the Arctic and is replaced by warm water which flows up from the tropics, a process called convection. Now, what they're talking about here is what's going on in the Jin Sea. After the northern end of the Gulf Stream gives off its heat, it sinks because it's now become cold, salty water. It sinks down, and in fluid dynamics, we have the principle, just like you have conservation of mass, conservation of energy, we have the conservation of volume. If water leaves from one place, something has to come in to replace it. Right? If it flows into a place, something has to leave to keep the volume steady. Just like when we have big oceanic gyres, Coriolis Effect piles water, to the center. If we're talking in the northern hemisphere, Coriolis Effect is deflection to the right. And if you pile this water up in the middle, it's going to go somewhere. We have what's called a downwelling in the middle of the gyre. That's for a clockwise rotating gyre. If it rotates counterclockwise, such as in the Gulf of Alaska, well, now Coriolis is moving water away from the center, so there's a void there. That void needs to be filled, which is the result of an upwelling. The upwelling brings nutrients, and that makes the phytoplankton happy. There's productivity, and it's no surprise that the Gulf of Alaska, which does have a counterclockwise rotating gyre, is a very productive region of oceanic waters. Anyway, I digress. But the point I'm trying to make here is that when the Gulf Stream reaches its end, gives off its heat and cools, it sinks. Well, that sinking will pull surface water behind it. So it helps move it along. If this starts to slow down, then the flow of the Gulf Stream to come in behind it will also slow down. There's also another problem. We're melting piles of the ice sheets of Greenland. That's fresh water that's being added to the surface. I'll be discussing that in more detail in a later video. So this is the first of a series of videos. March 19th of this past year, NOAA, National Oceanic Atmospheric Administration, reported that February's average Arctic sea ice extent was the smallest in the 39-year record. Its size was 521,000 square miles, which is 8.8% below the 1981 to 2010 average, according to the analysis by the National Snow and Ice Data Center, which is located in Boulder, Colorado. The monthly extent was 62,000 square miles smaller than the previous record set just last year. Now, there is evidence of similar disruptions to Arctic Ocean circulation in the past, but they did not persist. Okay? The study that I am sharing with you now is in the magazine New Scientist reports. If newer research bears out the scientists' findings, so far with ongoing research, confirming that the present Arctic warming is growing stronger and happening more often, the interplay of wind, ice, and meltwater could be contributing to changes in convection, then we can expect serious impacts on agriculture, weather, human well-being, temperature, and so forth over part of the globe. Okay, that's the first video. Stay tuned for the second video.